Hello friends, welcome to Inspire Maths. In the previous videos, limit of function part 1, 2, 3 and 4, we discussed the definition of limits. In this video, we shall discuss the Epsilon-Delta definition of limits. For that, we shall take a function f(x) equals x square minus 4 upon x minus 2. This function is same as what we took in limit of function part 1, so it is recommended to first watch limit of function part 1. Here we will take x not equal to 2 because f(x) is not defined at 2. If you look at a graph of this function, its graph is just like, if this is y-axis, suppose this is x-axis, then its graph will be, suppose that this is -1, this is -2, this is 1 and 2, this is 1 and 2, suppose this is 3, 4, its graph will be just like but at 2 it is not defined, so it will have a hole here at 2. This will be the graph of x square minus 4 upon x minus 2. Now we will find what will be the limit of this function, limit x goes to 2 f(x). For that we will draw the same table which we did in limit of function part 1. This is the table. Here is a left of 2, here is a right of 2. Here we have axis and f of axis. Here also we have axis and f of axis. Now in this column we shall take the points which are to the left of 2 but close to 2, and in this column we shall take the points which are to the right of 2 and close to 2, and we will look at the function values at those points, just like what we did in limit of function part 1. So if we take the first point to be 1.9 and look at f of 1.9, that will be 1.9 square minus 4 upon 1.9 minus 2, that will come out to be 3.9. Similarly, you take other points. Now we can take some points to the right of 2. As the first point to the right of 2, we can take 2.1, and if we look at a function value, it will be 4.1. Take more points. If we look at these two columns says that limit of f(x) as x goes to 2 negative is 4, that means the left hand limit is 4, and these two columns tell us that the right hand limit of f(x) at 2 is also equal to 4, and these two in combination gives us that limit x approach to f(x) equals 4. Now let us really look on these two columns. We have to approach the point 2, and the points which we are taking to approach point 2 are 1.9, 1.99 and so on. If I look at the difference between these points and the point 2, then I can note them here. I have 2 minus 1.9, that's equal to 0.1. Similarly, 2 minus 1.99 equals 0.01. and 2 minus 1.999 equals 0.001. I can go on. So if I look similarly at the points which we are taking and the limit which we are getting, if I look at difference between these two, I will get 4 minus 3.9, that's equal to 0.1, and 4 minus 3.99, that I will get 0.01. 4 minus 3.999, that I will get as 0.001. So what this thing says is that the lesser distance we take between the 2 and the other points, the less distance we are getting between 4 and the points which we are with the function values at those points. Now if I take some real number such that every point 0.1, 0.01 and 0.001 is less than that real number, then I have to take some number which is positive and small such that all these numbers are lesser than that. Let us denote by that number by this symbol, and this symbol we write it as delta. So I will choose delta such that this is less than delta, this is also less than delta, this is also less than delta. And suppose that we take some positive number such that all these are lesser than that positive number and that positive number is small, then I can name that positive number as epsilon, and I can take it less than epsilon, and this less than epsilon, and this less than epsilon. Then if I combine these, I can write down that 2 minus x is less than delta, because it's 2 here, these 1.9, 1.9 and so on represents the x values which we are taking in order to approach to 2, and this we are getting as 4 minus, these are the function values which we are getting at the point, these points, so we will take here 4 minus fx is less than epsilon. So this is whenever. So whenever 2 minus x is less than delta, 4 minus fx is less than epsilon. So this gives me the epsilon delta definition of the left hand limit of fx at 2. If I rewrite this by just multiplying minus 1 on both sides, I can write this as minus epsilon is less than fx minus 4 whenever 2 minus minus delta is less than x minus 2. So this thing gives the epsilon delta definition of left hand limit. Left hand limit says that whenever x approaches to 2, from the left fx goes to 4. This also says that whenever we take x's which are close to 2 at a distance less than delta, then these fx's get close to 4 such that the distance between fx and 4 is less than epsilon. Similarly, these two columns, if I take the difference between the x's and the point 2, we will have 2.1 minus 2. Let me write them here. Let me rub out this. Now if we look at the difference between these points and 2, we will have let me write them here. We'll have 2.1 minus 2, that is 0.1, and 2.01 minus 2, that's equal to 0.01. This is less than delta, this is also less than delta, and everything will get to be less than delta. Therefore x minus 2 will get less than delta, and at that time what will happen, the difference between 4.1 and the 4 which we are getting here, the 4.1 minus 4 will be equal to 0.1, which will be less than epsilon, and 4.01 minus 4 will be equal to 0.01 less than epsilon, and so on, so that we will have f of x minus 4 to be less than epsilon whenever x minus 2 is less than delta. So this thing gives me the epsilon delta definition of the right hand limit. So if I combine these two relations, you see minus epsilon is less than fx minus 4, so I will get here minus epsilon less than fx minus 4, but fx minus 4 is less than epsilon whenever minus delta is less than x minus 2, but x minus 2 is less than delta. So this is the combination of this and this, and this gives the overall definition of limit of a function, but the epsilon delta definition. So I can write it in terms of mods, but for that let me rub out this table first. So this is a combination of this and this, but I can rewrite it. We know that whenever mod x is less than L, that means minus L is less than x is less than L. So with this thing I can rewrite this as mod of fx minus 4 is less than epsilon whenever mod of x minus 2 is less than delta, because of this relation. So this gives me the final epsilon delta definition of limits. Now what does it mean? It means that whenever the x's are at a distance less than delta from 2, that means if I choose some delta here I choose some delta, and here I will take x's, here I will take a comb, and I will take all the x's in this region whose distance from 2 is less than delta. Then there is some epsilon here, such that the f of x points have the distance from 4 to be less than this epsilon. So this leads me to the final general definition of the epsilon delta definition. So definition is like this: let fx be f. So this is the definition. Whenever fx is a function defined in the neighborhood of a, then we say limit of fx is L as x approaches to a if the difference between f of x and L is less than epsilon, whenever we take the difference between x and a's to be less than delta. And this was it for this video. Thank you for watching this video. We'll meet in the next video where we'll discuss some more properties of limits. Thank you again.